Question number 2, log AP square equal Q. We want to explain this one. Log AP square, we know that when we multiplication we can write as a log addition, log A to the power Q. Then this third one come out, log A to the power P plus log A to the power Q. Then we have part B, log A P square Q equal 9. It means, what is this one? Log AP square Q is 2 log AP plus log AQ equal 9. Then log APQ equal 5. Log A to the power P plus log A to the power Q equal 5. So this is log A to the power P plus log A to the power Q equal 5. So this is going to be 2x plus y equal 9. This is x plus y equal 5. So I give this is as x, and I give this as y to for easy calculation. You can work like this one as well. So this is two simultaneous equation. We can solve this one. When you minus those two, 1 minus 2, this is going to be x equal 9 minus 5, x equal 4. From 2, when x equal 4, y equal 5 minus 4, y equal 1. I want to write let log AP equal x and log AQ equal y. Now x equal 4, x equal log AQ is 4, sorry, AP, and y equal log AQ equal 1. Question number 3, log Q to the power 16, and we want to write log Q to the power 2 in terms of P. The first attempt in this kind of sum is, we want to take this one, P log Q 16, then we want to see that we want to make log Q to the power 2 from 16. Can I write this 16 as 2 something? So I want to turn this one into get Q to the power 2. What are the technique of doing it? So P log Q to the power 2 to the power 4, if I write, then I know the third term I can bring forward. So I made now Q to the power 2 by writing 16 as a power. Now log Q to the power 2 is P divided by 4. I bring 4 down. Now we already found the answer. And the second one is log Q to the power 8Q. In this kind of sum, first of all, we need to look at the expansion, because q and 8 together, so it's difficult to handle. So log q times 8 plus log q times q. We know q times q is 1. So that's a good sign. And can I write q to the power 8 as q to the power um, q to the power 16 as q to the power 8? Or now in this sum we have two datas. We have log to q to the power 16 and another data log q to the power 2. Still we have in terms of p. So we can try to write either log 68. If we can write in terms of 2, then we can use this one. So log q to the power 2 cube 8 is log q to the power q is 1 now, and this is going to be 3 log q2 plus 1. Now, but log q to the power 2 is, we know, p divided by 4 plus 1. So 3p over 4 plus 1. Also a different approach. Assume if we don't have this one now. So this will given, we need to work out that one. Now I want to make 16, I want to turn into 8. 16, I can't write 16 in terms of power. 8 is by 64, that doesn't work. So 8 1 is 8 and 8 64, that doesn't work. Then what I'm going to do, I will take 8, then I'll bring into 2. So I will take 1/3. What is the 1/3 by 8 to 1/3? Third root. It's going to be 2. Now this value is 2 now. And 16 mean how many 2's? 2 to the power 4. Then this is 4. Then p equal log q to the power, instead of 16, I can write, when you simplify, you will get 16 here. 8, 1, so this is going to be 8, 4 over 3. When I expand, 4 over 3. Now this is going to be p equal 4 over 3 log q to the power 8. Then this is going to be 3p over 4 log q to the power 8. Q base 8. So then this is, I can write 3p over 4, and this is plus 1. Actually this sum is a guided sum. They will give guidance. Okay, first of all find q to the power 2 and then the other one. So we can use, we can get help of this one, or we can work straight like this. Question number 4. A 4 to the power x equal 23. Then we can use the first principle. Log, this is base and power. So base comes here, power goes outside. So this is 23. So this value is 2.26 approximately. And B 7 2x plus 1 equals 100. Now what is the base? This is the power. So log 7 base 100 we can write as 2x plus 1. So x equal the log 7 base 100 plus 1 become minus 1 and this is 2x. Okay, then x equal log 7 to the power 100 minus 1 divided by 2. You will get the answer as 1.27 approximately. And C 10x 6x plus 2. Now in this kind of situation, where's the base, where's the power? Okay, base, power, and there is no constant. Now this is now critical. In this kind of situation, we have to apply logarithm for both sides. Log. So I am applying with 10 base. If you want, you can apply with any base, but this is 10 base. That's why there is no sign. So 6x plus 2. Then this is become x log 10. So this is actually 10 base. 10 to the power 10 is 1. This is x plus 2 log 10 to the power 6. 10 base 6. So logarithm to the base 10 of 10 is 1. And this is going to be x logarithm to the base 10 of 6 plus 2 logarithm to the base 10 of 6. So then I want to take x in one place. I'll bring here x minus x logarithm to the base 10 of 6 equal to logarithm to the base 10 of 6. So should we write? We don't write 10. We don't write if it is 10 base. So x, when I factorize x1 minus log 6 equal to log 6, then x equal to log 6 over 1 minus log 6. So your answer should be around 7.02. Question number 5. 4x minus 2x plus 1 minus 15 equal 0. So we take 2 to the power x as u. Then this is going to be 2 to the power x square. Yeah, I'll take 2 steps. 2 to the power. I can write 2 square x. Then this is 2 to the power x times 2 to the power 1 minus 15 equal 0. Now I will switch this one 2 to the power x square minus this is become 2 times 2 to the power x minus 15 equal 0. This is, you can see that I will show you, this is 2 to the power 2 x. I can write 2 to the power x2 because 2 to the power 2x is 2x. This is also 2x. So that's why I switch this one, and then u equal 2 to the power x. This is going to be u square 2 times u minus 15 equal 0. So this is going to be u minus 5, u plus 3 equal 0, u equal 5 or u equal minus 3. It means 2x equal 5. So then x equal 2 to the power 5. This is we have to apply logarithms. So log 2 to the power 2 base of 5 is x. So the x value is going to be 2.32 approximation, and 2 to the power x equal minus 3. No solutions because the logarithm is not defined for negatives. There is no solutions. Question number 6. I'll show you common mistake children do. When they see this one, they will write log 2 to the power x plus log 2 to the power 10 because they are confusion with this one. Log 2 to the power. If we see a times b, we can write log to the power 2 a plus log to the power b. But log to the power a plus b, we can't write like that. This is only multiplication. Addition or subtraction, we can't do anything. Only addition, multiplication or division, we can handle. So this is a common mistake usually children do. When we have this one, we can see that this is negative. So then I can write this one as a, if it is negative, then I can write this one as a division. Positive one go up, the negative one go down. Equal 4. Now log base 2. Now we have to come out of log. So this is the power. This is the base, this is the power. So x plus 10, x minus 5 equal 2 to the power 4, which is 16. X plus 10 equals 16 times x minus 5. 16x minus 80 equal x plus 10. So this is going to be 15x equal 90. Divided by 15, x equal 6. Question number 7a. Y equal e to the power minus x. We want to differentiate. So dy over dx. First of all, we write the same answer. Same one. Then differentiate minus x. Minus x differentiation is minus 1. So this is going to be minus e minus x. I will tell again this one. Write the same answer first. Then differentiate. This is the command. What? Minus ax. When you differentiate minus ex, what is the answer? Minus 1. So minus ex minus. The next question is y equal e to the power 11x. So dy over dx equal, how do we write this one? Write the same one first. Then take this part and differentiate. So 11x times 11. So 11 e 11x. And the third one, y equals 6 e 5x. 6 e5x. dy over dx is, this is a constant, keep aside, multiply. Then rewrite this one, e5x. Then differentiate as usual the other part again. So this is going to be 6e5x times 5. So this is going to be 30. 6 times 5, 30 e5x. That's how this answer comes. But usually we don't write these steps because that's how in this book we are learning. When you have this one, by looking at it, we don't know what is going on here, but first of all 6, then 5 e5x. By looking at it, by observation we are doing. So by observation is not the right method. We don't know what is going on inside. So this is 30e5x. So if it is really, if I do again, I'll do a proper way, in detail, not proper, dy over dx. Okay. I bring operator d over dx, I'll keep both sides. Then this is going to be 6, I will take out d over dx e5x. Then what is this command? Eat e to the 5x, not eat, it differentiate. This command is differentiate. So then how do you differentiate this one? Write one more time 5x and then d over dx 5x. First of all eat this bit, that is done, then the rest one. So 6 times e5x times, this is 5. Actually when you done this one 5, then d over dx, the x. There is another one which may confuse you, I'll leave it. So 30 e5x. So this is how it is really moving. So instead of this one, we just y equals 6 e5x. Then we know that 6 is going to be here. Then 5 will come and we write the same thing. So dy over dx 30 e5x. This is okay for this one. By observation we are doing it. Yeah, regarding number 7 sum, the previous sum, yeah, don't disappoint that you don't know a lot of methods. No, that's fine. If you can write with by looking at it, that's fine. ln 2x minus 5 equal 8. Now we need to solve. Now this ln is a headache. Ln mean which base? E base. So 2x minus 5 is e to the power 8. Now 2x equal e8 plus 1 to other side. X equal e8 plus 5 divided by 2. Question B, e to the power 4x equal 5. Sometimes we have to take the log out, get rid of log or ln, and the other one we have to apply. So those are the only thing we have to do, either take it out or either apply. So in here we have to apply in terms of ln. This is base A, ln e 4x equal ln 5. So 4x come out, then ln e equal ln 5. So ln equal 1 because this is per 1. ln mean log e to e. and this e. So log e to the power is 1. So 4x equal ln 5, x equal ln 5 over 4. Or you can take the with the first principle, applying ln to both sides instead of that. This is base, this is power. So e to the power 5 is 4x. Sorry, I made a mistake. This is the way the log coming out. I switched that like this. 2x minus 5. The power is e8. Actually, I apply to the this one the same thing. So this is right now. So actually, this is the one I want to, yeah. So apply log here. So log e base 5 equal 4x. So for the first principle, um, and yeah, then x equal log e base 5 divided by 4. Log e base 5 means ln 5 divided by 4. Two different methods I apply. This is from the first principle. This is taking inverse, basically applying ln to both sides. Question number 8. This is going to be, I'll multiply by everything minus 24 equal e minus equal minus 10. See that this part I turn into a positive. Now minus ex equal, I just change all the symbols. Ex equal minus 10 plus 25. 24 e minus x equal 14. Now let's take the inverse. We take ln e minus x ln 14. Minus x is here. So ln e equal ln 14. This become 1. So minus x equal ln 14. X equal minus ln 14. Actually, there's a small problem. This is minus 2x. So this will become minus 2x, minus 2x. So then this will become minus 2. Sometimes they may ask the answer like this. Minus half ln 14. Then I bring minus half to inside. Then ln 14 I'll make positive. 14 over half. It means ln 1 over square root 14. Sometimes they may ask answer like that. Then you will be able to turn. So minus half bring inside, make it positive, and that's all basically. And this is ln x times x minus 3 equals 0. X times x minus 3 equal e to the power 0. X times x minus 3 equal 1. So x square minus 3x plus 1 minus 1 equal 0. So we have to write the quadratic equation minus b plus or minus b square minus 4 times a times c equal 2 times 1. So this is 3 plus or minus 3 to the power 4, sorry, b square. So this is 9 plus 4 over 2, 3 plus or minus 13 over 2. So x equal 3 plus 13 square root 13 over 2, or x equal 3 minus the square root 13 over 2 less than 0, because this is 3, if it is 9, it is still 3 more than 9. So then this is going to be a negative one. This is also going to be a negative. Log is not defined for negatives. Hence x cannot be negative, as log is not defined for negatives. So this is ex plus 1 over ex equal to, then multiply by ex, so ex times ex times 1 over ex plus 2 times ex. So e2x plus, this is going to be cancel out 1 and 2ex. So the same thing you can do when you see minus x, multiply by ex times ex plus minus ex. Objective is making this one 0 to ex. Then e 2x plus e minus x times ex equal to ex. So e2x plus 1 e0, 1 equal to ex. This is e minus x, ex, e minus x plus x is e0 equal 1. So e2x minus 2ex plus 1 equals 0. So this is ex square minus 2ex plus 1 equals 0. So this is ex equal y. So y square minus 2y plus 1 equals 0. So this is going to be y minus 1 square equals 0. Then y equal 1. So ex equal 1. So x equal ln 1. So x is going to be 0. So this is log addition. Then we can write this one as a multiplication. 2 times x, 2x equal 4. 2x equal e to the power 4. X equal e to the power 4 divided by 2. Log e to the power 2x. This is log not ln equal 4. Then first principles, you can see that this is the power, this is the base. 2x equal e to the power 4. X equal e to the power 4. So if you come confused the way it comes, that's how it is. Question number 9. So when you need to look at of this kind of sum, what is P and what is T exactly? P is the price and T is T start just after purchased. So that is the important thing. Part A, calculate the new price of the system just when you just purchase. It means new price when t equals 0. So p equals 100 plus 850 minus 0 over 2 e to the power minus 0 over 2. This is going to be 1 e to the power 0. So 100 plus 850, this is going to be 950. B, calculate after its price 3 years given you 3 years. When t equal 3, p equal plus 850 e minus 3 over 2. So this will you will get 289.66 and 290 approximately. And part C, when it will be worth less than 200. P less than 200. We can work as inequality this one, or we can work as a equality and then we can get the right sign. So we'll apply P equal 200 here, equal 100 plus 850 e minus 2 over. So this is going to be 100 when it's come to here. This is going to be 100 equal 850 e minus t over 2. Then e minus 2 over 2. I'll bring this one down. Sorry, 100. Okay, 0 to 0 cancel out. What else we can cancel out? And 5 times 2, 5 times 1, and 7. So 2 equals 17. E minus, can I write E t over 2 as a power? So this is going cross multiply. E2 over 2 equals 17 divided by 2. So this is going to be Et over 2 equals 17 over 2. So t over 2 equals ln 17 over 2. So t equal 2 times ln 17 over 2. That is 4 point around 28 approximately. Now next question is find the price when t goes to infinity. I always discuss two things. What is it? Et and e minus t. When t goes to infinity, et goes to positive infinity, et goes to positive. When t goes to negative infinity, et goes to 0. That's why graph is like that. When it's got to positive, it's going to positive infinity. When it's got negative infinity, it goes to 0. Now in here, opposite. T goes to positive infinity, et goes to 0 minus et. When t goes to negative infinity, minus e goes to positive infinity. We discussed last time, so it is this kind of graph. Now, in here, you can see that p equal 100 plus 850 e minus t over 2. Now, they want t goes to infinity. T goes to which infinity? Positive infinity they want. When t goes to positive infinity, you can look at from the graph as well. T goes to positive infinity, this is become 0. So this part is going to be 0. Then 100 plus 850 times 0. This answer is 100. So for bigger t value, worth of a computer is 100 pound. It means after, it's not going to exist infinite time, but after considerably big amount, around 10 years, we can think about 10, 15 years. But even when we put 10, 15 years, what is the e to the power minus, let's say 10 to the power 2? What is this value? So this value is about 0.006. In that case, 100 plus 850.006. It means still it's not multiplied by 850. It's plus 5 pounds something. Yeah, after 10 years, 105 something. So we have to put bigger t more than 10. So next one is sketch the graph. So first of all, you know what ET over to, okay. Our main person is ET. Then think about ET over 2. Then think about minus ET over 2. Then think about 850 minus T over 2. Then 100 plus minus ET over 2. So ET means this kind of graph. ET also that kind of with less. And this is when it is minus, it's going to be opposite. Then 850, it means uh, it is a vertical stretch. It's going to be something like this. T can't be negative, so there are no negative values. T has to be positive. No negative T's. Time can't be negative, right? So this is 850. Then what you have to do, you have to shift 100 over the setup. So this asymptote become 100 and the curve is going like this, and this is 800 become 950. So that's how you want to look at this. So I draw the graph like this, but make sure that never ever when you draw like this, don't bring like this. Usually it is happening when you draw very fast, it will go like this. So you will get 0 marks because this is the asymptote, so it's going to a asymptote and it will meet at infinity. So this is a good model. They ask comment on the above page. Yeah, it is a good model. Uh, Python usually computer has a value always. So computer is always worth some amount. Question number 10. The point P and Q lies on the curve with the equation y equal e to the power half x. The exponent of P and Q are ln and ln 16. So P x coordinate is ln 4 and Q x coordinate is ln 16. Now we need to find y. This is Q So y equal when x equal ln 4, y equal e to the power half ln x, ln 4. So we'll take 4 inside, y equal e ln 4 half. So this is going to be 4 half. 4 half, which is square root 4, 2. And the same way, y equal e for half ln 16. It means e ln 16 over 1 over 2. If you see e ln, so this is a good form. We can bring the number down. I mean, this is x. If you see this one, e ln x, simply write x. So having that in your mind, you can see that if you cease this half away, then take this half away, you will get this form. So this is going to be 6 half or square root 6, that is 4. So this is going to be 2 and this is going to be 4. So the first question is find the equation of PQ line. So then question number A, then gradient of PQ, y1 minus y2, x1 minus x2, change in y also. I'll take this one first. 1 minus 2 equal ln 16 over ln 4. This is going to be 2 over ln 16 over ln 4. Actually, ln 16 minus ln 4 means this is a subtraction. So we can write ln 16 over 4, which is ln 4 basically. So this is going to be 2 over ln 4. Then we can write y minus y1 equal m times x minus x1. So y minus will take this point, y minus 2 equal m. 2 over ln 4 times x minus x1 ln 4. So we'll expand y minus 2 equal 2x over ln 4 minus 2 ln 4 over ln 4. This is cancel out. So y equal 2 ln 4x and this minus 2 and minus 2 we can cancel out, remain. So basically this is the equation is going to 0, 0. So we have to show this is going to 0. So 2 ln 4 equal x. So we can write this is y equal mx form. Hence this is curve or line go through 0, 0. Or apply 0, 0. Then it should be satisfied. LHS equal y equal 0. RHS equal 2 times ln 4 times 0 is 0. Hence LHS equal RHS. Hence 0, 0 is on the point, on the line. But this is enough. PQ, length PQ we need to find. So we know that the equation is y minus y1 square plus x minus x1 square root. So 4 minus 2 square plus ln 16 minus ln 4 square root. So this is going to be 2 square plus ln 16. We work out that ln 4 square. So 4 plus ln 4 square over, so you'll get as about 2.43 approximately.